So, product discovery. Real science meets gaming. I'm Bergthor. I'm a senior development manager at CCP Games. Have been at CCP Games now for over 6 years, working on our flagship product, EVE Online. My background is actually in theoretical physics, so this particular project, like marrying games and science, really is close to my heart. Before I joined CCP, I did a lot of other software development things. If you, for instance, try to double book on BA flights, there's a process going on that kills one of the bookings, and that's probably a code I wrote back in 15 years ago or so. But before we go into the actual project, let's talk a little bit about citizen science. Citizen science is a fairly recent term. It only came into the Oxford Dictionary in 2014, I believe, along with citizen scientist. And in a way, it's this idea of getting a mass of people to actually do some real scientific work. It has also been called crowdsourced science or network science or crowd science. But citizen science is the term that is used for this when you are able to get a lot of people to actually perform something that, in the end, will further the evolution of man and our understanding of the universe. There have been attempts to do this in the past, or from the turn of the century. I don't know. This is a fairly young crowd, so they might not remember this part here. Oh, there are some people that have tried it. This is actually something I was personally really excited about when it came out. This is SETI Online, which was a search for extraterrestrials, basically taking in radio waves from radio telescopes, analyzing them, and trying to find patterns that could indicate that there was some alien playing a radio 3,000 light years away. And I was personally, really happy to allow the scientists to borrow a couple of my CPU cycles when I was not using my computer to actually analyze these samples. Now, technically, this is not really a citizen science project. This is much more akin to, it's basically an exercise in distributed computing, because even though that we are analyzing examples here for science, it's basically the computer doing all the work. But citizen science is basically using a similar idea, but using the fact that we, as human beings, are actually pretty damn good at pattern recognition. We are exceedingly good. We are so good that, in many cases, still we surpass computers doing that. But I might need to revise that sentence in 20 years' time or so. And some of the projects actually took advantage of that. This is a project from 2008, I believe, called Fold It, which was basically a small mini-game created, amongst others, by the University in Washington, where you, as a layman scientist or as a volunteer, could go in and take on a complex structure of a protein and try to fold it or move it into the correct 3D configuration, because it actually matters how proteins are configured, and even if they have the same chemical composition, the 3D configuration of the protein can mean radically different things when it comes to how it performs in the body, etc. So this actually gained some traction. Another great example is the Zooniverse, which is basically a collection of citizen science projects, probably the biggest citizen science project like Portal in existence at the moment. All started out by this Galaxy Zoo project in 2007, where you, as, again, just layman volunteers, were tasked with looking at images like the one you can see over there, figuring out, okay, this is a galaxy of, is it a spiral galaxy, is it an elliptical galaxy, etc., etc. So basically classifying images of galaxies. And what this showed us, along with actually the SETI Online examples, is that people are willing to spend their time in actually doing real science. The challenge with these particular projects is that it's fairly hard to retain people doing it. It's there is certain repetition involved. It's basically similar tasks over and over again, and getting you to come back. It has a novelty effect. You can try it out, but getting you to go back and consistently do it is a challenge for these projects. So, how about marrying this with probably one of the greatest retention machines known to us, which are the MMOs, or the multiplayer games, which are actually notorious for retaining people for years or even decades in some cases. And this is an idea that Attila of MMOS, or Massively Multiplayer Online Science, had. He basically thought, what if we could actually take examples like Zooniverse or like Foldit and get great developers to actually integrate it into a game that is already retaining people, already has all the facilities of getting you to come back day after day, week after week, month after month, and actually ingrain it into the game in such a way that it doesn't feel alien or out of place, but rather is part of the whole game experience. So that was his theory, and he wanted to try it out. And we at CCP were actually lucky enough to be one of the first companies that he contacted. For those of you who don't know CCP, we are the creators of EVE Online, which is a long-running, actually for more than 15 years now, single-shard multiplayer game where players basically, in a sandboxy fashion, shoot each other, build spaceships, shoot each other, market trade, scam, do whatever they want. It's a whole universe, whole experience by itself. And it has a really hardcore following. It's a great game. Try it out. It has a, I should have actually inserted a meme here. This is a Reddit meme of how hard the onboarding with an EVE Online is compared to other MMOs. But I just urge you to try it out and feel for yourself. But we're constantly working on that. But in any case, this is a sci-fi universe where science and science fiction go together. So this was actually a really great fit for us. And this is something that we took to heart and decided to give ourselves as a challenge. Can we take real scientific problems, real scientific challenges of this type, and integrate it into our game? So that was kind of the first task. The second one was, would we be able to actually get our players to play that part, play it and try it out? And the third, which was more of a practical reason, would it be possible for us to make it in such a way that it didn't disrupt the rest of our development efforts? We're continually evolving EVE Online, continually making it great, and so we didn't really want this to impact other development too much. So those were kind of the three goals we set ourselves from the start. And that led us to design principles. We wanted to select the correct scientific challenge to start with. And it had to have a certain attributes. The first one was, it would be a real world purpose of altruistic nature. Basically, we didn't want to aid some weapon manufacturer or something like that. We wanted to have it to be a real scientific challenge that would further the evolution of our understanding of how our universe works. It had to be fitting with EVE Online, its sci-fi setting, and adaptable to fit actually in the universe, making it a seamless experience for our players. So it didn't feel like you were actually doing something else on the side and then returning back to the game. It should be part of the game. a more practical nature, it must be like a constant, or a, it couldn't vary too much in the time it took you to actually perform a single task. And this was more to get the engagement correct, meaning that if it varied a lot, you couldn't rely on being able to jump into doing some real science and then go back to the game. And the fourth one was, it had to contain a lot of tasks. We're a multiplayer game. We have, hundreds of thousands of players, and we don't want this to feel too repetitive, at least not on the content level. The task itself, the individual tasks might feel the same, but we wanted a whole lot of information in that particular project. Which led us to the Human Protein Atlas. Now, Human Protein Atlas is a Swedish organization that handles images like these. These are immunofluorescent images of human cells, which basically means that they have been injected with certain dye elements, so parts of the cells lit up, and the green part, that's actually the protein part of the cell. And they have hundreds of thousands of these images. And those images fall into certain categories. And the task at hand is actually just to look at the picture like this and decide, okay, which of the predefined categories it falls into, the protein part, the green part. And look at these pictures. They are actually stunning. And this is just how it comes out of the scientific pipeline. These are the actual images that the scientists are taking with their microscopes. Actually, our art director was quite amazed that we don't need to do anything with it. We can just put it straight into the game and it will look beautiful. Because one of the things we want to look is stunning at all times. It might be 15 years old, but it is still stunning to fly around in EVE Online. So one of the things we wanted to do to actually ingrain it into EVE Online was that we used the character of Emma Ljungberg, who was actually the one that was spearheading this protein from the Human Atlas side, a really Swedish-looking woman. And we moved her as a character into game, so that you, as a player in the game, you were actually working for Emma Ljungberg, who is part of Sisters of Eve, which is one of the factions in EVE Online. So that was our attempt to actually get this more into the you're not doing this as part of the Human Protein Atlas. You were doing this for Emma Ljungberg, as who is for Sisters of Eve. Another part we did, which was more on the practical side, is the one I mentioned about previously, that we didn't want this to disrupt our day-to-day development too much. So with this being a fairly confined project, we wanted it to be ingrained, but it's fairly contained in when it comes to design and how it is put into the client. We decided to team up not only with the Human Protein Atlas and MMOS, who basically MMOS acts as a broker between the scientists and EVE Online, but also with the University of Reykjavik. So the implementations of actually both the first version and the second version, which I will touch upon a little bit later, were mostly done by interns out of the Reykjavik University, which was also one of the things we at CCP like to do to basically further the gaming community within Iceland, because that benefits us. In a pretty similar fashion, that I really enjoy this conference here. Wargaming is doing a great job in actually making this happen. So it was a bit of a gesture in that way. And actually, one of the two interns that worked on this project is now working on EVE Online full-time as a regular employee. And this led us to project discovery. Basically, got us to define that. And project discovery is basically a minigame within EVE Online that you can do whenever you like. For those of you that played EVE Online, you know that there is a certain, at least for certain gameplay types, there is downtime. While you're flying between systems, between markets to figure out the best way to sell a particular ship, or when you're mining, or when you are, market trading, etc., you will sometimes have time to jump into, product discovery and try it out for 3 minutes or 5 minutes, etc. So it's actually a pretty good fit for us. And the way it looks in the client is as follows. So I'm always pointing at this screen. Does that bother you guys on the... Should I point at this now? But in any case, what you can see here is the interface we used for product discovery. So this image here is actually coming directly out of the science pipeline provided to us by Human Protein Atlas just through MMOS. And on the right-hand side, you can see the 29 different categories that you can actually group it into. And in a way, the challenge is a bit more complex than that, because you can actually observe more than one type of protein in individual pictures. So it could actually be cytoplasm, but also like the nucleus or something like that. So there are different types. At the top, this was not the right button. At the top, you can see the basically your rank and your accuracy score. The accuracy score is something that MMOS actually calculates. And the way it does that is that based on your submission, we have what we call a gold standard, meaning that we have images where we know the result. So, and for the Human Protein Atlas, we actually injected like around 15% of the samples you got once you got to a certain level were of this gold standard. And those were actually used to calculate your accuracy. So that if you got the gold standard right, your accuracy would rise. So in order to identify the protein, you actually allowed you to do something we called like color filtering. So you could actually, here a person has actually removed the blue color. And you could also like select individual elements here and see examples of images that contain that particular protein. So the challenge was, it's quite visual. It's actually quite stunning. It's a pity we don't have it in the client yet, but it's really nice. Once you had selected, then basically your decision is sent to MMOS, and which then either updates your accuracy score and calculates basically recalculates your accuracy if it's a gold standard. And when we, if it's a gold standard example, we give you feedback, okay, this was a correct choice. And we actually use this, for instance, there's a tutorial for this where you are basically, we get you to run through like 10 or 20 samples and, of various complexity and try to figure out exactly what it is. So we try to teach you how it works, but it's kind of intuitive from the get-go. And at the end, Emma comes and gives you analysis credits and gives you rewards. And you can actually use then the credits to purchase apparel or purchase skins for your ships, etc. And one thing we do as well is if it's not part of the gold standard, we actually register it as a this is your decision, this is your this is how you identify the sample, and if sufficient a number of players identify the sample the same way, we say that we reach consensus about the sample. It takes usually like 15 to up to 50 submissions, depending on how much variety is in the answers, for a sample to reach a consensus, which literally means that the body of EVE players have decided this is a cytoplasm of this particular sort. So how did our players react? Actually, it blew our mind. So basically, in the first 24 hours when it went live, we had over 460,000 classifications done. There were 14,500 images that reached consensus, which is quite amazing. And one of the top tier prizes that we put out, which was this Sisters of Eve combat suit that Emma is donning there, 45 of them were sold in the store. So obviously our players loved it. And I'll go into a little bit more numbers. I won't show it, but I'll tell you that Project Discovery ran from March 2016 to July 2017. In that time, around 320,000 individual players participated once or more in doing the classifications. So it was a big chunk of people that tried it out. And they performed just under 33 million classifications in that period, which is quite amazing. And actually, to moderate, or basically make sure that this will never be forgotten within EVE Online, we erected this monument in one of our systems. You can actually fly there, and you can, if you read the information about the monument, you can actually see who made the most classifications, etc., etc. So this is just a permanent structure in EVE Online from now on until the end of time, where you can actually see the contributions that the players made. But more importantly, and this is probably the things we are most proud of, the scientific community is a little bit slower than the gaming community, so even though the project ended like more than a year ago, it was only this September where the results, the formal scientific results, came out as an article in Nature Biotechnology. And we even got a Stradios on the front page of Nature Biotechnology. I don't know how many of you are scientists or know science, but this is the equivalent of getting to the front page of Rolling Stones. Or if you're a certain president, to get to the front page of Time magazine. So it's for scientists, this is huge. Just to get an article in one of these Nature magazines is phenomenal, and to get on the front page is, blew our mind. We're so proud of this. And basically, the end results are that the conclusions of the EVE players married with an AI process that the scientists were working on at the same time, together, they managed to find 10 new types of proteins. And even though the AI was better than the players at identifying the most generic samples of proteins, for the rare cases, the EVE players outclassed the AI, which actually then created a learning set for the AI to get better. So basically, what EVE players contributed to is that we now have an AI process that is much, much better at identifying those cells than before. So real scientific contribution. But even though we stopped the Human Protein Atlas, basically because we had analyzed all the samples we could get our teeth on, we decided to do something else. We really liked this fact, so we wanted to bring something else to the table, and actually something that we had kind of wanted to do from the start, but weren't comfortable about because we hadn't tried it out. We wanted to do exoplanet search. So before I go into exoplanets, we actually added one extra line to our design principles. We had basically set the expectations with Project Discovery. Our players expected a certain amount of complexity and a certain amount of depth to the challenge. And the next iteration of Project Discovery should be of similar nature or at similar complexity. And exoplanets fit that. So exoplanets, those are basically planets like the Earth or Jupiter that orbit suns that are different from ours. And those celestial bodies are notoriously hard to find. because planet or distances in space are astronomical, and those bodies are quite far away. There have been some indications all the way, I think the early 20th century, were the first indications that we might have found some exoplanets, but it's only in 2012 that the scientific community reaches a consensus that we have found an exoplanet. So it's fairly recently that we've actually acknowledged that we've found planets around other suns. Currently, there are just under 4,000 exoplanets that have been confirmed, but we want more, and we are, continue looking for exoplanets. And, in the long run, it might actually be a requirement for the success of the human race going forward. But there are multiple ways of finding exoplanets. One of them takes cue from what happens within our own solar system. What you can see here is Mercury passing in front of our own sun. It's a time-lapse image, so you can see how it travels there. And if you were to measure the luminosity of the sun, you would actually see a little dip in the luminosity graph while Mercury goes away. Mercury is, of course, a fairly small planet. It would be a bigger dip if something like Jupiter passed in front of it. Although we don't see it because we have an inner circle than Jupiter. So basically, in theory, it's how it works. Here at the bottom, you can see the luminosity graph, or basically brightness, tracked out as a function of time. And when the planet is not in front of the sun, it has the same luminosity as before. And once it starts to enter the circle, it goes down. And when it's within, it stays low. And once it passes all the way through, it goes back up. So it's a luminosity graph. And these luminosity graphs are provided by us by University of Geneva, taken from, I think we now have examples from at least 2 telescopes. And this is the guy that is spearheading it all, Meyer. He's actually retired, but he's still working on this. And he is, in EVE Online, we introduced him the same way as we did for Emma Lundberg. And he's actually working for Concord, which is kind of the police and intelligence agency in EVE Online. We did this partly to get rid of basically the extra currency we added in the first project discovery that Sisters of Eve had, the analysis credit I discussed, because we found out that adding a new currency into a game that is already as complex as Eve isn't really a good idea. So we moved factions and hence got rid of the analysis credit, so basically Concord took over project discovery. In real life, Meyer is actually kind of a rock star within the exoplanet community, because he is one of 2 that found the first exoplanet, confirmed exoplanet. So it's a real treat to actually have him as head of this institution there. So the way it works is quite similar as for project discovery, although the challenge is different. You can open this up wherever you are in space, or if you're at docking station, or if you're flying your ship, etc. And what you can see here is basically there's a luminosity curve on top, over here. You can actually, I don't know if you can see it at the back, there are a handful of dips in it, and we'll elaborate on that a little bit. The same curve is actually represented in the middle, and that's because we want you to be able to zoom into the curve to actually better see if there's a dip, or if it's something irregular about the curve. At the bottom, there's a single sun that has no planets at the moment, but we will add planets to it once we have identified the transitions. And this is just a visual cue. We found out that just looking at graphs wasn't really exciting enough, so there's a little, there's a little solar system moving there at the bottom once you start filling out if you find planets, etc. And we even added some secondary classifications, which is down here to the right-hand side, over there. Like if it's a pulsating star, or if it's it's actually not a planet, but a rotating binary, then the dips are much deeper when one sun goes in front of another. And we did that kind of because in a way, looking for exoplanets is like looking for a needle in a haystack. We got hundreds, probably like just under 200,000 samples to start with, and we only had like 3,000 gold standards that we could use to actually say, this is a type of transit we want to mark. And out of those 200,000, like a really rough estimate was that we would probably find somewhere around 9 ± 3 exoplanets in that whole set. So literally, it's like looking for a needle in a haystack. So we decided to embellish this with a little bit of extra information to basically retain the depth that we had in Project Discovery Human Protein Atlas. So basically, you start marking on the top graph. You just click the dip there, and then a planet will appear. There's actually 2 dips. One is here, and there's another one over here, you can see. So you can actually extend your selection to contain them both. And then you get an option to fold the graph, basically bring them together to see if, to align it. There's another function here we introduced called detrend, which is basically trying to remove these regular oscillations of the star itself. These might be oscillations of the star. It might just also be some oscillations in the instruments themselves. So once we have both folded and detrended, we get something like this. And you can then align the 2 dips, or the 2 valleys, to coincide, and then you say, okay, this is where it is transiting, and what we get out of that as well is the orbital time, or orbital period as well. So it's traveling around at a certain period. And as before, you can zoom in on that, and finally, you push submit, and if it's a gold standard, we will actually send this is actually a success, give you an indication that this is, you've completed the analysis. And again, at the top, there's like your level and your accuracy score. This was actually I captured these just having, a new character, so they didn't have any attributes. So it's actually 0, the accuracy score up here. It will go up in a short while. But basically, it's the same process. Here we see it. It has gone up a little bit. So Meyer comes and gives us additional rank, and that additional rank will basically give us then, the apparel or the ship skin that we basically gave out as rewards for this. This is type of the apparel with this really nice, like logo here with a transit idea, and some of our players fly around in these ships with the Project Discovery Exoplanet logo on, or actually because it's Eve, you can just sell the skin on the market and somebody can fly it without having ever done any Project Discovery. But hey, that's how it works. So this is still ongoing. There are probably like 500,000 light curves in the system right now. There are around 160 million submissions so far for this. Not all of them are legit. I'll go into that a little bit later. But it's like 5 times the amount we saw for Project Discovery, the Human Protein Atlas. So what are the key learnings from this and some of the key challenges? Well, first of all, one of the things we set out was to answer the question, do our players like it? And the answer is a resounding yes. So here we see basically percentile participation. So it's like of daily users, how many engage with the feature. And you can see here at the leftmost side, it's where the Human Protein Atlas started. And here is when we started the exoplanets. This little dip, or this little top here is when Eve went free to play with the Alpha and Omega clones. So you can actually, you don't have to pay subscription anymore. You can actually play Eve for free. And you can see at the start of basically each project, there's a novelty aspect of it that a lot of players try it out, etc. And this is to be expected. But what we are really pleased to see is that it tapers off at like a steady, for Human Protein Atlas, it's like a steady, like 3-ish% of players engage with it every day. And for the Exoplanets, it's more like 5%, which is, great. It means that people are repeatedly coming and doing this as just part of their regular EVE sessions. And that was what we wanted to achieve. Also, our players embraced the fact that they were doing real science. There is actually, we brought both Emma, who's here, and Michel Meyer to our EVE FanFest. Actually, on this picture here, you can see Emma. This is a prototype we ran on a FanFest where players were, just trying out a prototype of the Human Protein Atlas. And this guy here is actually Hjalti, who is the intern that's then turned CCP employee. And this is Hilmar, our CEO, and they are really excited to look at those players try out to sort out proteins. And here's Michel Meyer. He's talking to the Space Pope, who is really famous within the Max Singularity, who is really famous within the EVE community, an avid EVE player, but he also works for the NASA Jet Propulsion Laboratories, so he's one of the few people alive that can actually claim he's making, real-life spaceships. So it's people love that. The press, they actually loved it as well. We got a lot of positive coverage because we were tackling product discovery, which is always a nice thing. And also, for the players, we also did sentiment reports and plowed through our forums and Reddits, etc. And overall, the consensus is extremely positive. People just love doing this. People love to feel part of something big. And basically, what I explained before, this is kind of the ultimate goal, to actually make a difference, to actually make us as a human species know a little bit more about our universe and how it works. For the exoplanets, the only thing I'm allowed to say is that the initial results are promising, but I can't say anything else, unfortunately. So, but I hope that in the near future we'll be able to claim some exoplanets for ourselves, but no promise there. There are, however, a handful of challenges that we faced. For the Human Protein Atlas, it was basically about game balance, meaning that the cytoplasm example of human proteins was by far the most common one. So because the way we set up the ranking and accuracy rating, etc., players could actually just spam cytoplasm as a category, and still, the accuracy rating wouldn't fall below a certain level. So they could actually just spam that and still get rewards. So we had a little bit of difference or difficulty to start with to actually balance that out and figure out a way to stop that. For exoplanets, we had a little bit of different problem. So this is the number of daily classifications for both actually Human Protein Atlas and then the exoplanets. And as you can see, there's like I told you, the first day it was like 470,000 classifications. It dwindled off to a steady some 50, 60, 70K throughout the lifespan of the Human Protein Atlas, kind of fitting with how many players are participating in it. But for the exoplanets, it starts out really in a similar manner. The exoplanet challenge is actually you're much, or can be a bit quicker about doing it, so it takes a little bit less time. So that's the reason why we have more exoplanets here. And it all looks pretty good and seems to be like tapering off at like 200,000 submissions per day. But then something starts to happen. It's, it goes up a little bit and down a little bit, and we're not really worried. It might just be, at the interest or some of the corporations in EVE Online saying, hey, this is a great way to make money, go do it. But then in the summer, something really starts to go wrong. What we found out is that our players, some of our malicious players, had found a way to identify the gold standards that we sent out, because there are fairly few of them, like 3,000 in the whole set. There might be a little bit more right now. So what they did, they had managed to create automation that actually identified and knew these gold standards And for the rest, they just spammed no transit. So out of these 160 million samples, like my guesstimate is that probably like 100,000 of them are legit. The rest is just bots spamming no transit. This is more a problem for EVE Online rather than the scientific research, because if enough people are actually doing it and finding those rare instances where you see a transit, we are fine with having a lot of like null results on top of that. So it doesn't really harm the scientific part of it, but it harms the economy because we are giving out rewards and etc. So we actually put some measures in, just everyone was on summer vacation here. We put some measures in. They started to affect, but obviously there's some work to be done here, and that's the status as of like late last week. So there are still some botting to be found, but that's just how things works. But overall, the conclusion is that we basically managed to hit all of our goals. We managed to ingrain this into EVE Online in a fashion that it doesn't feel out of place, even though it's a mini game. Because of the lore reasons, because of the rewards, because of how it's basically you get rewards that actually help you progress in the game. It feels part of the game. Our players loved it. They like to engage with it. They like to actually be able to go do a little bit of real science and just go back then to the gameplay. And they are also really proud of the fact that we have contributed to science, and that is reflected in community research and just comments. And we also managed to do it without upsetting our development process by a lot by actually teaming up with a university. So all in all, this has been a great experience for us in EVE Online. This is a work we are really proud of, and I'm personally really proud of our player base to be able to participate in this, actually engaging with it. And this is definitely something that we'll carry on doing in EVE Online for the foreseeable future. I actually think that Project Discovery will be with us as long as people are flying their Stratioses or Ravens or all the other ships in EVE Online, because our community really, really likes this. And I would actually urge other games to try this out. It is important for science. There are like billions of hours spent, playing online games. And if you can just siphon a little bit of that into, doing work like this, it will actually help us just as a human race. And I think that's an important lesson. And that is my last slide. Thank you very much. So I believe it's question time, right? Yes. How am I on time? Okay, it's pretty good. Hands up, please. Or are you just stunned? Yes.
You're going to give shoot first.
Thank you for sharing your research. I want to ask, didn't you want to make these mini games as a separate games, because maybe complexity of EVE Online may be stopper for even more people to participate in this research?
It's a good question, and actually, funnily enough, some of our scientists, especially for the analyzing the light curve or the luminosity graphs, they said, "Oh, we would actually love to have this as a separate client just to work with the light curves." But the crux of the matter is that you want the retention part. You want players that are already engaged to do this, because if we could publish this as separate clients, but then they would basically face the same issue as the Zooniverse and Foldit examples, that in the long run you would not get as many classifications. Now EVE Online is a pretty good fit because the way the gameplay works, you have actually downtime between the tasks that you're doing. it might not be as fitting for some other games, but I think that the retention is key here. So get people to do this every day or as part of every session, basically. And I know that EVE Online is considered to be hard, and it has been evolving for 15 years, and it's a dystopian sci-fi game that loves, uses a lot of community engagement, etc. So, and has a steep learning curve, I must admit. It is a fairly hard game. But I think that if we had just published it as separate mini games outside of EVE Online, it would not have been as successful. It might have been more successful if it was grained in World of Tanks or World of Warcraft or some game that have much bigger audience than EVE Online has. But EVE Online has a pretty sizable audience and pretty hardcore audience that repeatedly go into the game client. So I think in the end, it would have been a failure to try to do this as minigames. Let's put it that way. We might do a mobile version, though. That could be an option. Next.
Hello, Kimmo Kari from Finland. Since I have also this physics background, I have a bit more scientific question. I didn't really understand how only that light curve would define an exoplanet, because you need a certain orbit, and then you would need the mass of the star and the mass of the planet to really calculate that is it in this in a good range. So is it like pre-selected material that is in the game, or how is this
No,
taken account?
in the example I showed, you basically have two transits of the same planet, and that's what gives you the orbital time, because it has actually gone twice around the sun. Okay. And then you can use just Kepler's law to calculate the orbital size, etc. But basically, it's the orbital time actually that you calculate. That's just a simple calculation based on you have two dips, so you know that there is like 30 days between or something like that. So that is
okay. No, I'm not into cosmology so much, so I cannot really claim.
But basically, you see, you literally see the planet circle 2 times. The time frame we have is 28 days. So we actually miss out orbits that are longer than that, or orbital times that are longer than that. But in some cases, planets are really close to the sun, so they actually move around quicker than 28 days. So we have examples of that.
Okay.
But in general, it's just a single dip. So
okay.
I just wanted to show the folding of the folding functionality.
Okay. Thanks for the great presentation.
Thanks.
Thank you for your presentation and your time. I'm Rob Vieira from Wargaming Sydney. My question is more about where does the idea come from within CCP, whether it's from the business or from a team or whatever. How did that evolve? And what was the challenges that you actually faced, if any, internally to get it to be a live product there?
Okay. So you're basically speaking of how we got the buy-in from the company to do this, or?
Yes, and
yeah. Well, basically, as I explained, Attila from MMOS came and contacted basically Andy Nordgren, who was the executive producer of EVE Online at the time. And she and Bergthor, who is our current basically visionary for EVE Online, they immediately understood that there was something in there, and that would actually fit really well for EVE Online. So we actually had buy-in from the top, from the very start. So basically, Andy Nordgren made sure that we had the resources we got. Bergthor, who was then a project manager, but is now our creative director, he basically ran with it, managed to get the first iteration going, and then actually one of my teams took over when we went for the Exoplanets stuff. So we had a buy-in from the start. We have a really good cooperation with the University of Reykjavik, so we are basically helping them to have courses on game development, etc. So there is really interest from that side also to be able to show that their students can actually come and do some real gaming work. So it's a lot of factors that came to place, but I think one of the key factors is the fact that this was a buy-in from Andy as the executive producer from the start. So I think that's there were some challenges in getting interns in and getting them to work on work with the development teams, because obviously we need assets for this, so we need to work with the art team, we need to work with basically some of the game development teams to get QA time to test this out. There were additional complexities because we're actually contacting an external service, which is not that common in the EVE infrastructure. So there were multiple challenges, but overall it went really well. Probably time for a handful more.
I'm not sure if you can share this with us, but are there any ideas of other further researches that you can do based on EVE Online after you finish the Exoplanets search?
There are. Well, I can't go into the details, but basically we have, the design principles that I set up are there for a reason. That's because we actually have evaluated more than just these 2 projects, and there might be more in the future. Currently, we feel, as long as we're getting feeds from either new feeds from the same telescopes or feeds from different telescopes, we feel that the exoplanets are probably the best fit right now. But of course, we would like to bring more challenges and leverage this in a different manner. But currently, there are no plans to do it. But once we get there, if we get there, we will basically use these design principles to figure out, okay, what is the game challenge here? How can you make it ingrained into EVE Online, etc. I think that's it. Thank you very much. It's been a great crowd.